Okay, let's continue working on an example. So we mentioned about if one of the line that it's vertical, how to find the angle between this vertical line and another given line. So for example, find the angle between the line x equals to 1 and 2x minus y plus 5 equals to 0. Okay, so now all the vertical lines have the equation x equals to something. So therefore, this is the vertical line. Since it's vertical, so we don't need to worry about the gradient of this line, which is undefined. So all we need to know is the gradient of this given line. So 2x minus y plus 5 equals 0. We have moved the y to the side that is easier. So therefore, y equals to 2x plus 5. And here is the gradient. In other words, therefore, tan theta is equals to 1 over 2, given this formula, when one of the lines is vertical. So therefore, theta is simply just tan inverse half. If you put it in a calculator, that will give you 26.5650. If corrected to nearest minutes, that would be 26 degrees 34 minutes. Okay, so that becomes a bit easier when one of the lines is vertical. Okay, let's do one more in case you want to see a little bit more example about a general how to find the angle between two lines. Find the angle between the line L1, which is 2x plus, let's say, 3y minus 5 equals to 0. And L2, let's just make this easier this time, just y equals to 3x minus 4. So in this case, now we are given two lines. One is in general form, one is in gradient intercept form. So the gradient intercept form, which is easier to see, the gradient is just 3. But the other one for L1, you have to change it back into gradient intercept form first in order to find the gradient you need. So therefore, this is the gradient. And M2 is equal to 3, which is right here. Okay, so now once we get that, therefore, the angle between the two lines, tan theta is equals to M1 minus M2, it doesn't matter which one you use, over 1 plus M1 times M2. Okay, so if you chuck this everything into the calculator, the top one should be negative 2 on 3, 2 on 3, minus 3, over 1 minus 2, which will give you 11 on 3. Okay, and therefore, theta is equals to tan inverse of 11 on 3, which would give you 74.7448 something degrees. And if you correct it to minutes, it's 744 degrees, 45 minutes. Okay, right, so that's basically all we need to do for the angle between two lines. Okay, so homework. this time is a little bit weird because it's not in the coordinate chapter we have been doing. It's exercise, still the year 11 book. Let me check. Should be chapter 14. E. Question 14E. 1, 2, 4, and 7 and 8. That's all. Okay, that's all you need to do for this section. I'll put up more example or more exercise when I come back.